Hello everyone, myself Vinay Kumaram. I'm actually pursuing PhD in physics. So in this particular YouTube channel, I'll be teaching physics, chemistry and mathematics starting from 8th standard till 12th standard. If you want to learn physics, chemistry and mathematics, then please do subscribe to my channel and stay tuned with my channel. In my previous videos, I was actually discussing the 7th chapter of 9th standard science subject, that is motion. So in those videos, I have actually discussed about velocity, speed, distance, displacement, etc. So now in this particular video, we will be learning how distance, velocity, time and acceleration can be studied through various graphical representations. So in graphical representation, the first graph which we will be studying here will be distance versus time graph. So here you are actually considering two physical quantities. So that is distance and time. So now distance is one particular physical quantity and time is another physical quantity. So now if you take a particular graph, a two-dimensional graph, then there will be two axes in it. So one will be x-axis and the other will be y-axis. So we are taking distance on y-axis and we are taking time on x-axis. So now we have to scale this graph. So each individual unit on y-axis will be equal to 5 meter. So now you should always remember scaling is very important in a graph. So here you will actually give 1 unit covers how much the physical quantity which you are taking on that particular axis. So here 1 unit on y-axis will be equal to 5 meter. So this is for y-axis, and if you are considering scale for x-axis, let's say 1 unit will be equal to 1 second or 1 unit will be equal to 1 minute. So on x-axis I am taking minutes, time in minutes. So 1 unit will be equal to 1 minute. So now the first unit will be 1 and the second unit will be known as 2 minutes, because here difference between 1 and 2 is again 1. So that's why 2 minus 1 will be 1. So the each unit will be getting 1 minute itself. So here also on y-axis, if I take first unit as 5, then I have to take second unit as 10, because difference between this 10 and 5 will be 5. So again this particular scale of 1 unit equal to 5 meter will be remaining as it is. So now again I have to add this 5 for the third unit. So that will be 15 unit, the 15 meter. So next it will be 20 meter. So it goes on like that. So I'll take up to 25 meter. Here also on x-axis it will be 1 minute, 2 minute, 3 minute, 4 minute. That means I am increasing with 1 minute. That means each unit is equal to 1 minute. So that is what the scale we have taken on x-axis. So I'll take up to 5 minutes. So let's consider a vehicle moving on a particular road where it covers 5 meter in 1 minute. So now when it covers 5 meter in 1 minute, then you have to draw a perpendicular line from 5 meter and one perpendicular line from meter. So the point of intersection of these two perpendicular lines will be the point where that particular vehicle has covered 5 meter in 1 minute. So now the same vehicle will cover 10 meter in 2 minutes, let's say. So the next point will be here. So the same vehicle, if it covers 15 meter in third minute, and if it covers 20 meter in fourth minute, and if it covers 25 meter in fifth minute, then you can see here there is a linear graph forming. That means here this particular vehicle is in uniform velocity. So why uniform velocity? Where did velocity come into picture here? Because here you are considering distance and time only. There are only two physical quantities, one is distance and one is time. Where this other physical quantity, that is velocity, coming into the picture. So here, if you consider this as a straight line, and if you consider the slope of this particular straight line, then here this will be y and this will be x. So this particular distance you can actually multiply with the scale, and this particular distance, this particular time on x-axis you can multiply with this unit. So now the slope what you take for a linear graph will always be equal to the y divided by x. So y is actually this particular distance. So here you can see in this graph, so this particular distance is y. With this you should actually see on the graph how much unit it is covering, and you should multiply that with 5 meter. And here this is x value, where you have to take this particular unit on x-axis and multiply that with 1 minute. So you'll get the value for y and x. So when you do y divided by x, you will actually get the slope. So now if you consider this particular distance versus time graph, where the graph is a linear graph, here at this particular point, and if you are considering this particular point, if you draw a perpendicular line from this point and if you draw a perpendicular line from this point, then this particular point on y-axis will be distance 2 and this particular point will be distance 1. And if you draw a perpendicular line from this point, then this particular point will be t1, that is on the x-axis, and if you draw a perpendicular line from this point, that is the second point where you are considering. So these two are the points. This is the initial position and this is the final position. Let's assume that. Let's say this as A and this as B. So it has got displaced from A position to B position. That means here it is actually covering distance d1 to d2. That means you should actually, if you want to calculate the total distance covered, then you should actually subtract d1 from d2, because that will give you the distance covered from A to B. And here time taken at d1 and time taken when it was at d2. So that will be t1 and t2. Now if you want to calculate average velocity or the average speed of this particular vehicle, so now that average speed will be equal to the distance covered divided by the time taken, the total distance covered divided by the time taken. So what is the total distance from A to B? That will be d2 minus d1, because you don't know what is the distance between A to B. So that's why we are actually drawing this perpendicular line towards y-axis, so that we get this initial and final position, that is d2 and d1. So that is d1 and d2. So now the subtraction of d2 and d1 will give you the total distance. So d2 minus d1 will be the total distance covered divided by, we have to take total time. So time taken from t1 to t2. So to calculate the time taken to cover d1 to d2 distance, that means that particular distance between A and B. So the time taken will be the time, the t1 which was there at distance 1 and the time which was there at distance 2. So if you subtract those two times, you will get the total time to cover that particular distance. So here t2 minus t1 will be there. So the same equation what we discussed when we actually discussed about average speed in our previous videos, the same equation you can actually derive from this particular graph as well. So that means here this particular average speed is actually calculated from this particular graph. So in this particular graph, the graph was very much linear. So that means this particular vehicle was covering equal amount of distance in equal amount of time. So that's why if this is distance and if this is time on x and y axis, and if the graph is linear, then here you can say that this particular vehicle or this particular object is uniformly moving. That means this particular object has uniform speed. That means it is maintaining the constant speed where it is covering equal amount of distances in equal amount of time. So that's why this graph actually represents uniform speed. Now what if a particular object is in non-uniform speed? So if a particular object is in non-uniform speed, then this graph will not be linear. So that means it will be covering certain distance but not equal distances in equal interval of time. So in first interval of time, it might cover this much distance. In second interval, it might cover this much distance. In third interval, it might cover only this much distance. And in fourth interval also, it might cover the same amount of distance. And in fifth interval, it might actually cover this much distance. So like this, if it is an irregular graph where the linearity is lost, then that particular distance versus time graph will tell you that this particular object or this particular vehicle is in non-uniform motion. That means this particular vehicle or object is not maintaining constant speed, constant velocity. The velocity is actually varying. Now if you want to calculate the instantaneous velocity and instantaneous speed or velocity, then at this particular position what will be the distance, and at this particular position what will be the time. You can just take this particular distance and this particular time. So d by t will give you the instantaneous speed or instantaneous velocity. If you are considering displacement, it will be instantaneous velocity. So here in calculating instantaneous speed or velocity, you just require the amount of displacement happened at that particular time. But when you have to calculate average speed and average velocity, at that particular time you should have the total distance or the total displacement. In the case of speed, it will be total distance, and in case of velocity, it will be total displacement divided by total time taken. So this is the formula which I have actually discussed in my previous videos for average velocity and also for average speed. So when you actually plot a graph for distance and time, you will get an idea about speed. That means this graph is actually giving you the information about distance, time and velocity. So now let's say acceleration is also involved in this particular case. So when the acceleration comes into picture, then you have to include velocity and time in this particular two-dimensional graph. So velocity already includes distance. So when you are actually talking about velocity versus time graph, at that particular time you are actually talking about distance and time already in velocity, and versus time will give you an idea about acceleration as well. So now if we actually look into velocity and time graph, so in velocity and time graph you are actually considering velocity on y-axis. So velocity will be on y-axis and time will be on x-axis. So now let's suppose say a particular object or a particular vehicle is moving in an uniform speed or in a uniform velocity. So that means it is covering equal amount of distance in equal amount of time. So what might be the graph? So the graph will be parallel to x-axis like this, because you can clearly see we have taken velocity, not distance or displacement. So when we have taken velocity in the y-axis, here you can clearly see the velocity is very much constant. So let's say here somewhere around 30 km per hour is the constant speed of a particular vehicle. So at that 30 km per hour, you can actually draw a parallel line for x-axis. So this is x-axis and this is parallel line to x-axis. That means here velocity is not increasing. So here you can see velocity is not increasing like this and velocity is not decreasing like this. So it is actually maintaining a constant velocity. This particular object or vehicle is maintaining constant velocity. So that's why this line is parallel to x-axis. That means in equal interval of time, it is covering the same amount of velocity. That means in equal interval of time, this particular object is covering equal distances. So when it is covering equal distances, then velocity will be constant. So that's why there is no increment or decrement in velocity. It is just going parallel to x-axis. So this actually shows a particular object is in uniform motion. That means here if you take slope of this particular line, you don't get y value at all. So when you don't get y value, so let's say slope is equal to y by x. Here you can see if you take slope of this particular straight line, y will be 0 because the line is parallel to x-axis. So y will be 0. So here when y becomes 0, it will be 0 by x. So what is 0 by x? Yeah, 0 divided by anything will be 0. That means slope is actually equal to 0. So here y is velocity and x is time. So that means here indirectly you are taking velocity and time. So since velocity is constant, y becomes 0. Since y has become 0, 0 divided by x is giving you the 0. So that means here acceleration is 0. So when acceleration is 0, this particular object has uniform motion. That means this particular object is moving with a uniform velocity. So this is how you should actually derive the acceleration from velocity and time graph. So what is the acceleration in this particular case? Acceleration will be 0. So now let us take another case. So here in the same velocity and time graph, so let's say you are taking y and x axis. So velocity will be on y axis and time will be on x axis. So if a graph is very much linear like this, so at that particular time you can clearly see equal amount of velocity increment is there with respect to equal interval of time. That means in equal interval of time, the velocity is equally increasing. So that means in 1 minute or in 1 hour, if a car is traveling in 30 kilometer per hour speed, then in next hour the same car will travel at 60 kilometer per hour, and in next third hour the same car will travel at 90 kilometer per hour. That means equal velocity. So that means velocity is constantly increasing with respect to time. So this is actually uniformly accelerated system. So that means there is uniform increase in velocity. So here this is not a uniform motion. So this particular system, you can actually call this as uniformly accelerated system. So that means there is uniform acceleration. But you should remember, this is not an example for uniform motion. So if it was a distance versus time graph, then it was a uniform motion. Then it would have said, if you have a linear graph on distance versus time graph, then it might be uniform motion. But here, if you have a linear graph for velocity and time, then it doesn't represent uniform motion. It represents the uniform acceleration. That means this particular system is uniformly accelerated system. So now, if you are actually considering the next case, that is here if you are actually considering velocity and time where the graph is very much irregular like this. So let's say graph is like this. So that means here you can see velocity was increased and then velocity was decreased, and again velocity was increased, velocity was decreased, again velocity is increased as the time is progressing. That means here the system is not in uniformly accelerated system. There is variation in acceleration. Once it is actually accelerating, then it is decelerating, and then it is accelerating, then it is decelerating. That means here uniformly accelerated motion is not there. Here non-uniform acceleration is actually happening. So this particular system or this particular graph gives you an idea about non-uniform acceleration. If you are considering, so let's say if you are considering the same graph, velocity on y-axis and time on x-axis. So here if you are considering point A and point B on this particular straight line, and if you are actually drawing a perpendicular line from A and a perpendicular line from B on x-axis, so the area which is actually covered under this straight line between these 2 points, that is this particular shaded area what I have shown here. So the area of this particular region will give you the distance traveled by this particular object. So now if you are actually considering another graph, let's say there is a velocity and time graph like this where velocity is constant. So velocity will be constant. Let's say this is the graph. So that means velocity is constant here. So when velocity is constant, if you are considering this point, that is A point on this graph, and there one B point on this particular graph. So from this A to B, you are actually covering certain amount of distance because you are having a particular velocity, constant velocity. So the area under this particular curve will give you the distance traveled by that particular object. So in this particular VT graph, similarly, when there is uniform acceleration as well, so if you consider the area under point A and point B, you will get the distance traveled. So whatever the area will be there for the region which you are taking below the graph, that is from point A to B, so that particular region, the area of that particular region will give you an idea about distance, how much distance this particular vehicle has covered. So this is all there in this particular video. So like this, if you want to learn more physics, chemistry and mathematics related to 8th standard, 9th standard, 10th standard, 11th and 12th standard, then you have to subscribe to my channel. Please do subscribe to my channel and stay tuned with my channel. Thank you.